Okay, let's talk about the non-standard normal random variable, and now we're talking about x. In this case, u can be any real number. It could be positive or negative. Sigma is any non-negative number. So in this particular example, we will have to be given, if we're talking about x, a mean, in this case of 100, and a standard deviation of 5. And we also must be told that x is normally distributed. We'll have to be told that. So watch for these keywords. Okay, we have to be given this. We have to be given the mean and the standard deviation, and we are. So here's our mean, this 100, given standard deviation, given x is normal. Okay, so we'll have a question like this in the homework. Find the area to the right of. Once again, mean in the center. Now our mean is 100. 107 is bigger than that number, so it's to the right. And we want the area to the right of that. Now, we can convert these to z-scores if we want to. We don't have to. I'm going to just do that just to illustrate a point. If I do, these are x values here. If I do convert to z, this z-score for 100 is 0, and that's our standard z-score formula. If we do 107 minus 100 over 5, that is 7 over 5, which I believe is 1.40. So the reason I'm doing this is I want you to understand that this is the exact same thing we did in the PennCast, where we had standard normal with z. It's the exact same method. So it used to be that before we had our calculator, we'd have to use the z and look it up in a z table. Now we don't have to. We can go right to our normal CDF function, just as we did in the prior PennCast. If you didn't watch that one, I recommend you watch that one before this one. We put our lower bound, so this is just as we did before. Our upper bound is infinity, which remember, as I said before, is represented as E99. We must put the mean and standard deviation in this time because that is not our default value of 0 and 1. Again, if you didn't watch the first PennCast on standard normal, then you might want to do that. That will explain some of these things. I will now type these values in, and I get, what did I get? What did I do? That doesn't seem right. Oh, I'm sorry. I have a mistake, no wonder. This mean is 100, not 107. I could tell that because my answer did not make sense to me. Okay, this makes a lot more sense. The answer, the area that I've shaded is 0.08. When I round, that's what I get. So that area right there is this. And that again would be the same as a probability that x is greater than 107. Okay, so here we go to part B. We put the area in the middle. 88 is to the left of 100, and we want the area to the left of that. So I'm going to shade that area. Remember, this would be the same thing as asking for the probability, same thing as area. So we will once again use normal CDF because we're finding area. We always use normal CDF. We want to go from negative infinity to 88. Mean of 100, standard deviation of 5. Once again, we could get z-scores. There's no need to do that. If you want to get the z-score, you could use your z-score formula. The z-score for this one is negative 2.4. Kind of gives you a sense of how far away that value is. So the area to the left of z equal negative 2.4 is the same as the area to the left of z equals 88. Same thing. Okay, so once again, I'm going to use my normal CDF. And let me get this value. And that's a very small value because we're even more standard deviations away, 2.4. This area is 0.0082. Let me write something here. Area is never negative. While the z-score can be negative, this area here is never negative. Okay, last one. Find the area between these two values. Once again, mean in the middle. 90 is over here. 105 is over here. I may not have this to scale. I could get z-scores. There's no need to get that. Remember, this is the same as a probability. And we want normal CDF. We want to go, our lower bound is 90, our upper bound is 105. Our mean is 100. Our standard deviation is 5. Oops, I made a mistake here. 90. Okay, and I'm getting 0.8186 when I round. And that, once again, is this area right here between those two values. And remember, this one is that right there.